Hello everyone, it's Salman. In this video I want to show you how to set up a project for a LoRa node with STM32F103. First of all, open the CubeMX and go to Access to MCU selector. Next, in the part number, type STM32F103C8. I want to use ST-Link version 2 for debug, so I select serial wire and I want to use an external crystal for clock source, so I select crystal ceramic resonator. And in clock configuration tab, enter 72 here and hit enter, then click OK. Make sure you enter the right crystal frequency here. I use an 8 MHz crystal, so I entered 8 here. In the connectivity peripherals, we need an SPI for communication. I use SPI 1, select full duplex master, and make sure that the baud rate is lower than 10 megabits per second. So I select 8 for the prescaler, and it is done. Then we have to select some GPIOs. For example, PB0 as output, PB1 as output 2, and PB2 as an external interrupt. Now in the GPIO section, I want to set some labels to them. PB0 set as NSS for chip select, and PB1 set as RST for resetting the module, and PB2 set as DIO0 for getting interrupts from the module. The most important thing is that NSS and RST pin should be initially high. Now it's okay, and in the project manager we have to set some settings. In the code manager, select copy only necessary library files and check this one. This option helps you to have a clean project. Now in the project tab, set a name for this project, for example LoRa underline node underline 1. And I use Kale Microvision as a compiler, so I select MDK ARM and yes, generate the code and click the open project. This is our main.c file. I collapse these functions, we don't need them, and let's compile it. Okay, no error, no warning. Now I want to import LoRa library to this project. So I'll go to my GitHub page. I pinned this library here as LoRa. Now we have to clone it. I copy this URL and open the command line and go to my desktop, for example, and use a git clone and paste this URL here and hit enter. Okay, it is done. Now on the desktop, this is my main project I publish on the GitHub. I just copy the LoRa folder and go to a recently created project. And paste it here. That's right. Now in the Kale, first of all, in project setting C++, include paths. Now add a new one and select our library folder. and hit OK, OK. And here, add a new section as my drivers and add file LoRa.c. Now it is here. Now I include our library here and compile it again. Now it's ready for programming. I've written an initial configuration guide in this section, so follow this instruction. First, we need to create a global LoRa structure in user could begin PV or user could begin private variables. And this is here. Then call its constructor in our user could begin 2 here. Now we should set these necessary parameters. NSS, GPIO ports, and pin. I used RST label for this, and also SPI1. Now we have to initialize our LoRa module by calling LoRa underline init function. And my LoRa, yes, this function will return LoRa underline OK if the connection was created successfully. So check this by a condition. Now I use a variable called LoRa underscore stat, and in the if assign 1 to it. Let's compile the code again. It's okay. Now we can send data via LoRa module. So I use an array called txBuffer in the size of 128. This is our maximum packet size. Then I assign some random values, for example 45, and the second cell, for example 0x12 in the hex, and the third cell can be a character, for example G. Now by using LoRa underline transmit, we can send this data. The second argument is our data buffer. Here it is txBuffer, and the size of data we want to send here is 3 bytes only, and the timeout, it can be, for example, 500. Now this code can transmit data to the other nodes on the LoRa network, and data will be broadcast. It is the main idea. It means all of the nodes in the range can receive this packet. Now, what if we want to receive data too? I want to use an external interrupt, so write whole underline GPIO underline EXTI underline callback, and go to its definition using right click and select go to definition or press F12 on the keyboard. Then copy this function declaration without the weak keyword and paste it between user could begin 4 and user could end 4. Delete these useless lines. Now in the callback function, first we need to know that which GPI pin has been triggered as EXTI. So I write an if for it. If GPIO underline pin equals to DIO0 pin, do something here. Now we have to enable continuous receiving mode first. So after the initialize function, I call LoRa underline start receiving. After this line, our module starts receiving data from the other nodes continuously. Now, if we receive a valid LoRa packet, our EXTI callback will be executed. Now the only thing we need is to store this packet in an array. So I use a LoRa underline receive and the array I want to store the packets to it, and Rx buffer, and size, it is the maximum size, it is 1 to 8. Now I define an array called Rx buffer to store the packet. And it is done. Now if a valid LoRa packet was received, it will be stored in Rx buffer and we can analyze it in the while loop, for example, or any section of our code. We can add some additional settings, and those are here. Copy and paste them before initializing function. These parameters related to LoRa protocol settings. For example, central frequency of modulation, spreading factor, bandwidth. You can use autocomplete for change this parameter. For example, here 31.25 kilohertz, and coding rate and transmission power 20 dB, for example, overcurrent protection, and the preamble. The most important thing is that all of these settings should be similar in all nodes, except transmission power and overcurrent protection. The other settings should be same. And now our STM32 LoRa node project is completed and is ready for uploading to the microcontroller. If this video was helpful for you, please don't forget to donate to me and start my GitHub repository. Thanks for watching.